Welcome back to the e-bike builder channel. In this video we're going to be exploring flashing open source firmware onto the Tongsheng TSDZ8 mid-drive motor. So when we flash when we flash that open source firmware onto the motor controller, it kind of like changes the behavior and the code that controls the motor. So it's going to fundamentally change kind of like how the motor operates and processes all the input signals from the torque sensor. This motor has a torque sensor, so it's good for e-bike builds where you want to do pedaling and actually like ride a bike like a bike. So I wouldn't recommend this TSDZ8 motor if you just like want to throttle around on the streets going as fast as you possibly can with the motor. For that, I would get a hub motor. Right, so this TSDZ8, I've been experimenting with this lately, seeing if it's kind of like a viable option for mountain biking, is specifically what I've been using this for. Right, so I want to investigate, kind of like try out the open source firmware. I'll show you how to flash it from my computer, and we'll get it on there, and then I'll kind of tell you about the problems that I'm having with it so far. And I don't know. I'm just gonna kind of, I'll just show you what I've learned so far and run you through the process. And, but I mean, to be honest, guys, like I'm still kind of having problems with it myself. So this isn't like a one-stop guide to getting it working. Like if you're gonna do this, I would expect to do some debugging and have to tinker around with things and, you know, play around with. You might have to research some error codes and try and figure out what's going on. Like it's not, right now, my experience has been that like this thing has been kind of difficult to work with. So let's get started. So the first thing we want to do, I want to plug the programming thing into the bike. But the first thing you want to do is unplug the battery, like totally disconnect your battery. Right? So if your battery has an on or off switch, you might just be able to turn the battery off, but like I would totally disconnect it from the motor just to be sure, because if there's a battery connected to the motor and you plug in this programmer thing to the motor at the same time, then the battery and the programmer can supply power to the motor and you can actually damage your motor, right? So first up, disconnect your battery, completely disconnect it. Make sure that your bike isn't able to turn on, because you don't want any power from the battery connected to the motor throughout this process, right? So there's this programming thing. I guess it's called like a Sager J-Link, and this isn't a real Sager J-Link. This is like a Chinese fake emulator Sager J-Link that I bought on AliExpress. And so I'll put a link to this programming kit that I bought on AliExpress in the description of this video. But I basically bought it on AliExpress as it was marketed as a TSDZ8 programming kit. So it came with the J-Link thing, the programmer, and then it also came with this little wire that you need to connect it to the TSDZ8. And so this wire, it's like the speed sensor. It's got 6 pins in there, and it's got kind of like a flat side on one side of it, so that you can only plug it in one way. And so how I've got it connected here, I'll put the wiring pinout on the screen, but there's 4 wires that I had to plug in to the bottom of this thing, and you have to plug, there's 20 pins on the bottom of this thing in this JTAG connector. So I've just manually plugged in each of these individual wires to the proper spot. So I'll put something on the screen that shows that wiring diagram, but this is the programmer. And right now I have it connected into my computer. I guess the protocol, like the best protocol, is to disconnect it from the computer first, or so I think. But I've done it both ways. Like I've just left it plugged into my USB on my computer and just disconnect this from the bike, and I've never had any problems doing that. So the wires on here are a little bit short, And what I've been doing is I bring this programmer up onto my chainstay, and then I take like a Velcro strap and then kind of cinch this thing on here on the chainstay so that the wires are close enough so that I can plug them in right here. So there's that guy. So then and this thing plugs into the speed sensor. It plugs in where the speed sensor usually would. So I'm going to disconnect my speed sensor on the chainstay, and then we're going to plug in the programmer to where the speed sensor was plugged in. All right. So now the programmer is plugged into the bike, and I'm going to plug the USB into my computer. And Microsoft Windows went ba-dow. All right, so I'm gonna get a screen recording going so that you can see my screen here right about now. All right, so we're on my computer. So I'm gonna show you guys where I got this open source firmware from and just kind of like get you caught up to speed here. So let's go. And we're gonna go on Google and we're gonna search for mstrens OSF. And then that should bring us to GitHub. And so there's two versions of this open source firmware. There's this first one, this OSF, and then there's the second one, OSF _ 860. And so how this works is that I think originally the OSF one was kind of the first version of it, but then after a while they made this OSF 860C version of it, and that one is a little bit more advanced. You need a specific display, like an 860C display, and then apparently that's kind of like the best setup is if you have that 860C display, because you can program the parameters of the motor and you can kind of calibrate the torque sensor and look at debugging information easier with that 860C display. And you can actually like program the motor and stuff from the 860C display, which would be very convenient. But I don't have the 860C display. It costs like $130 or something for an 860C display. So I haven't committed to buying one of those yet. I just wanted to try out the open source firmware, just the basic version without the 860C display. So that's the one that I'm using. But if you have an 860C, I would probably look into that other one so that the programming process, you can kind of program it straight from the bike without having to plug in this programmer thing over and over and over and over and over and over. But for all of us who don't have the 860C display, I'm just going to start with this one as the one that I've been playing around with. So this is a GitHub project. GitHub is a website where developers upload their source code, and it's like a source code repository where it keeps track of every version of your source code, and that's how developers work on their software projects, right? Is they keep their code in like a source control system like Git. And GitHub's kind of like an online cloud version of Git that a lot of people use, right? So we're on GitHub, and this list right here is all of the files that are in the repository. And then if we scroll down, there's a README, and the README is kind of like the instructions that the developer of the project has provided. So let's just go through the README quick, and I'll just kind of run through this quickly. So it says this repository, so it's kind of like this project, is a fork of this Mbruza project that was developed for TSDZ8 Tongshan motor. The purpose here is to have a version that can be used on a TSDZ8 Tongshan motor. Changes were required because TSDZ8 uses a different microprocessor internally. So there's kind of like different electrical things in the TSDZ8. So this version was created, and it's kind of like based on the TSDZ2 version, right? So it can be a little bit confusing when you're working with a project like this, because the main developer of this project is the one that made the TSDZ2 firmware, right? But then the one that we want to use for the TSDZ8, this is like a separate project that was kind of like copy pasted from the TSDZ2, and then it's modified to work with TSDZ8. So it kind of makes things a little bit tricky. Like when you're looking at the manual and stuff, you got to go back and forth and like look at the manual for TSDZ2, and then like go double check the manual for the TSDZ8 and stuff like that. But so the TSDZ8 version is a little bit different than the TSDZ2 version. The TSDZ8 needs a J-Link device. That's what I just plugged into my bike, and we're going to use in a second here. It uses the J-Link device instead of an ST-Link device to flash the firmware and the configuration in the controller. So it's kind of like two projects, very similar, but one's for the 2 and one is for the 8. And then so there's like a bunch of warnings, right? It says there are probably some bugs, and I would agree with that assessment. It says this is just a beta version. Try it at your own risk. So this is like the developer telling you that you're probably going to have to like mess around with it, and there's going to be bugs, and it's not going to be perfect, and you're kind of on your own. Like you're going to have to talk on forums and troubleshoot things and stuff, right? So it says to use this firmware, you will have to download the firmware, use a Sega J-Link device and a cable, flash the compiled firmware on the TSDZ8 controller, generate a file with your preferences using the GUI configurator. Flash the hex file that has been generated with the configurator, fine-tune some parameters, and they say it's optional, but from my experience, like I couldn't get the torque sensor working until I completely calibrated it manually, which was not easy. And I don't even know if I'm going to talk about that in this video, because it was like a rabbit hole figuring that out. But okay, so it says, let's get started with this. So it says download this firmware. It says download or clone this repository. If you download it, unzip the archive where you want, right? So so I'm going to go back to the top, and I'll show you how we can download on GitHub. So you see this green button that says code. Right here, you click on code, and then it pops this little thing up. And so if you have like a terminal, you can just do like a git clone, right? Like there's terminal commands that nerds can use to easily clone a project from GitHub. But if you're not a nerd and you don't want to dink around with terminal commands, you can go right here to download zip. Click on that, and then it'll download a zip file. So in this case, it's called OSF main, and then I've already downloaded it, so it's like OSF main, and it's giving it like a number after it. So let's save that out. I'll just show you the process. So we save that out. And then Windows is probably going to do like a virus check or something. Okay, so let's go look at this. All right, so I'm in my downloads folder. So here's that OSF main zip file. So this is a compressed file that has a whole bunch of other files inside of it. So it's like a folder of files. I'm assuming y'all know what a zip file is, but you have to extract it, right? So you do extract all. And then once you extract everything, you can see all the files on your disk. So I'm just running like the built-in zip file extractor that's built into Windows. So now you can see it extracted this, and then here within this folder, if we drill in, here's all of the files that exist
within, like, these are all the files we downloaded here. So like all of this stuff is basically the same as all of this stuff right here, right? Like these are all the files from that we've downloaded from GitHub, okay? So that's kind of how we pull that down, right? And then, so I'm gonna go back down to where we were. So you need a Sager J-Link device, and I think it's like the J-Link V9 is the one that seems to be the one that we need, and that's the one I got. So I've actually got like the Chinese J-Link clone V9 from AliExpress. And so here's where it talks about like the J-Link wiring. So like this is the information right here that I used to figure out how to get all of these little wires plugged into the J-Link. So if you click on this, it shows you the diagram of the J-Link connector, right? So here's that J-Link thing that is on the bottom of the J-Link where I plugged all those pins into it, right? So you have to look at this thing. And I think it was like pin 7, pin 9, and then pin 4 and 6 or something. Let's go back and look at that. Let's make sure. But you basically need to go onto this picture and reference this picture, and then look at right here. So you need to plug red into pin 7, black into pin 9, brown into pin 1, and then orange into pin 4. And that's basically what I've did right here with these 4 wires that are sticking into the bottom of that thing, right? So now it says to flash, you can follow instructions from here to know how to use J-Link. So I'll just show you how it works. So there's like this software that you download somewhere. It's called the JFLash. And it was on this page somewhere, like some kind of like files that I found. But you just gotta look around. There's like a zip file that you download with a few files. And it was, let's see if I can go find it. Let's go to my downloads. It was called like TSDZ8 programming kit files is what I downloaded somewhere. And I had this J-Link Windows v612a.exe. So this is how I installed the J-Link software on my Windows computer. And it needs a Windows computer, apparently, unfortunately. But we're on Windows. I've double clicked this thing, right? And I've already installed J-Link. Right, so I'm just gonna exit out of that. But like when you're done installing J-Link, you wanna search on your computer for JFLash. What is happening here? Oh my God, Windows. No, I don't even, how do I have TikTok on my computer? I don't even use TikTok. What is going on? All right, but so like if you look on your computer and you say JFLash, assuming that Windows can still find it in this day and age. So there's JFLash, there's the application that was installed on my computer. I've already got it running here, right here. Okay, so like what I did was, so I'm just gonna close this. So like, no, okay. All right, so when you start up JFLash, it looks like this. So what you wanna do is you wanna do a file, open project, and then inside of this TSDZ8 programming kit files that you've downloaded, there's this Z8 750 watt 1.6.jflash file. So this is the JFLash project that we want to open up and load into JFLash. So we open that. And then so when you open the project, it kind of like over here on the left, this thing shows you some information like host connection, target interface, you know, all this stuff. So it just, the project is, it seems like just kind of like some settings, right? So in here, so it says project opened successfully. So now the next thing that we want to do, so what I'm going to do is right now I have the open source firmware on here, right? So like it's already on here and I can't really show you how to flash it on here unless I revert this thing back to the factory firmware. And I'm actually a little bit curious if I put the factory firmware back on the motor, if it's gonna work or not, because I haven't tried that. Like, I've basically just flashed the open source thing on here, and then I've been experimenting with it, but I've never done it the other way around, where I put the old firmware back on here. So I'm just gonna show you quick how I'm gonna bring the factory firmware back onto my thing. So we're gonna like bring this thing back to the factory state that it came in. So and I'll show you how to do this in a moment, but like the first thing that you want to do when you connect this JFLash thing to your motor is you want to save the original firmware and make a backup of that onto your computer, so that if you ever have any problems or you want to go back to the factory stock firmware, you have a backup that you can flash back on there to restore it, right? So that's what I'm going to do right now, just to get back to like a factory state. Okay, so I'm going to go to File and then open a data file. So the data file is like what we actually want to flash. And then, so if I saved out the stock firmware in this specific spot right here. So TSDZ8 stock firmware powalin.hex. So this is my backup. Okay, so I'm going to open up the stock firmware data file. It's 155 kilobytes. And then so when we flash the firmware to the motor, there's kind of like two different ways that we can use this JFLash thing to flash to the motor, right? Like, so there's this production mode when you go into target, and then production programming. That, what it does is like it erases everything on the motor first, and then it writes all of the data to the motor. So it's kind of like when you do a production programming, it's kind of like clear everything off of there first, and we're starting from a clean slate, right? But then when we do the open source firmware, it's a little bit different. You have to flash the firmware, and then you have to make a configuration file, and you flash the configuration file on top of the firmware, right? So basically, like whenever we're flashing the firmware, we want to do the production programming so that it erases everything, and then it flashes the firmware. And then after that, if you're using the open source firmware, you got to flash the configuration as well. But so right now I'm gonna use the production programming to restore the factory firmware. So we're gonna go to production programming, and what this is gonna do, it's gonna clear everything and then flash this data file that I've loaded here, the Powalin factory firmware. It's gonna flash that on there. So let's get the factory firmware back on there. We gotta connect first, actually. So go to target connect. And so it says connected successfully. So that means that we're connected. Our little programmer thing is connected to the motor. And then we're gonna do target production programming. And it says target erased, programmed, and verified successfully, all right? So we should have just flashed like the stock firmware onto this thing. So I'm gonna close that data file, and then I'm gonna it looks like, I don't know, I'm just gonna totally close the JFLash software now. I'm not gonna save the project. All right, so now that we've done that, I should have flashed the factory firmware back onto it. So like, what we have to do now is we have to disconnect the J-Link programmer from the motor, and then I'm gonna plug the battery back in, and we should be able to turn on the bike, and it should hopefully be in a factory state now. Okay, so it does seem like it's gone back to the factory firmware, because
when you start up the open source firmware, you can kind of see like numbers and like things happening and stuff. So it does seem like, I think if I put it onto 1, yep, so it's working again. All right, so we're kind of back on a clean slate. So that was a demonstration of how you can flash the stock firmware back on there, and it's also good to see that that still works. It's a little bit of a relief to me because I might be going back to that, to be honest, if I can't figure this out. All right, so now just imagine we've got a stock TSDZ8 with a stock firmware. So I'm going to disconnect the battery again because I'm going to show you the process for programming for flashing the open source firmware onto it. All right, so I'm going to disconnect the speed sensor again, and I'm going to plug the programmer back in here. So now the battery is unplugged, programmer is plugged back in. All right, so now let's put the open source firmware on there, right? So I'm going to open the JFLash. I'm going to open that recent project that we previously opened. So we're back in JFLash. We opened the project. Let's connect to the motor. So we've connected successfully. So now what we're going to do is we are going to flash the open source firmware. The first step is we want to flash the open source firmware, and then after that we have to generate like a configuration hex file, and then we flash that hex file on there too. So I'll show you how we flash this open source firmware on there. So let's see here. So I'm going back to Segger JFLash. Let's go. So I'm going to open up the data file that has the open source firmware that I want to use. So I'm going to go into these the files that I've downloaded from GitHub. So that's this open source. This is the OSF main. So this is just like the GitHub repository where I've downloaded that whole thing from GitHub. And then let's see here. Like there's this folder that's called Files to Flash. And I think the one I was using was just like the most recent one. So it's OSF TSDZ8 VLCD5 Katana V00_01_33, right? Because when I come over onto this GitHub, and then we go look in the files to flash, the most recent one is this one right here from last month, right? And that's the one that I've selected. So if you're trying this in the future, it's possible that there might be newer versions of this firmware. I would look for a file that has a bigger, just look for like the most recent OSF TSDZ8, you know, just look for the most recent one. It might be like a newer one when you're watching the video. But so this is the most recent one for me, this V00_01_33. So that's the one that I've been using right here, 000133. So I'm gonna open that. And so when we flash the open source firmware, we wanna do it in the same way that we flashed the factory firmware, right? You load up the project, you load up the data file with the firmware, and then you go target, production, yeah, we're connected, make sure you connect first, and then production programming. It says target erased, programmed, and verified successfully, completed after 2.523 seconds. So I'm going to close that data file, and then we're going to go back to the GitHub and continue going through the instructions, right? So the next step is to generate the configuration file. So it says the configuration file is generated with the same tool as TSDZ2, JavaConfigurator.jar. But then there's an important note here. A copy of this tool is provided in this repository. You have to use this copy because there can be some different parameters depending on the versions. So what that means is the TSDZ8 JavaConfigurator.jar is different than the TSDZ2 JavaConfigurator.jar. So when you're using the Java configurator, just make sure that you're using the one that came within this TSDZ8 code,
right? So we have to use the JavaConfigurator.jar to make the configuration file. Basically, let's see here. So I've got this JavaConfigurator.jar. It's started off right here. I'm gonna close it. And then I'm gonna go start it up again. So we'll gotta go into, so just go into wherever you downloaded everything from GitHub, the OSF main. And then in here, there's a JavaConfigurator.jar. And so a jar file, like this is a Java executable kind of like Java application, right? And so you need Java installed on your computer to be able to run this jar file and launch the application and use it. So if you don't have Java, just go on Google and search for download Java JRE. So that's the Java runtime environment. And then you go to, it's from Oracle, java.com. Go download Java. And then just click on one of these, like Windows Online Installer, Windows Offline Installer, right? So you gotta download this thing and then launch it, and then use the installer to install the Java runtime environment, right? So then once you have the Java runtime environment installed on your computer, you should be able to just double click this jar file to launch that Java application, and then it brings up this parameter configurator. So this is the little application that we use to make the configuration file that we need to flash on top of the open source firmware, right? So it's like two-step thing. You flash the firmware using production programming, and then you flash the configuration file using the manual programming so that it doesn't erase everything, and it writes the configuration on top of the open source firmware so that both things are there, right? So this configurator, it does seem like it pulled in my most, actually, I don't know. I don't know if it pulled in my settings. Let's see here. That is really weird. All right, so we're in this Java configurator, and I'm a little bit confused because I am fairly certain that what I had selected was TSDZ8. So I don't know what exactly happened there. Really weird though, because it seems like some of these values, it pulled in like this pedal torque ADC offset and this pedal torque ADC max. It seems like it pulled that in from somewhere. Didn't I just make a new, did it load my, I don't know what's going on here, boys, but this is the configuration thing. That is so weird. It must load your most recent settings when you open up this configurator, but like this dropdown was not set to the TSDZ8 like I would expect. Let's see here. Let's click on some different ones. Oh, so when I click on this, it shows TSDZ8. Oh, now it's weird. I think there might be a bug here with this thing. That is really weird. Let's try that again. So let's open that up. So it says TSDZ2 right here in the drop-down now. But when I load my settings, yeah, when I load my settings, it still says TSDZ2. That is so weird. It seems like it pulled in everything else except for that. That's weird. All right. Excuse that confusion, but so I've been messing around with this parameter configurator for, I don't know, a couple days now, like trying to get this thing to work properly. And it just, like, I'm having some problems with it, to be honest. I'm seeing, like, I'm able to flash this on there, but like I'm seeing some error codes and stuff when I'm actually riding the bike that are making it pretty unreliable. But we'll talk about that when we get there. So these are kind of like the settings that I was trying to use. Like I would expect, I think the settings on the factory one were like 21 amps max battery and like 1150 watts motor power max. So then I changed this overcurrent delay because I keep getting this error 7 and it's related to this overcurrent delay. And I tried to increase the overcurrent error delay to see if it would fix the error, but like I keep getting an overcurrent error, and that's my main problem at this point. So there's all of like these settings that you can play around with in here. And I'm not going to explain them right now, but I'm just going to say that I've basically I've been playing around with these settings for the last few days that I've loaded in here. And let's see, are all of my things still seem right? Seems like it. So these are basically the settings that I'm going to use, right? So then when we want to save this settings file out as a hex data file that we can flash onto the motor, we go down here to compile hex file. And so it says TSDZ8 underscore config.hex ready in files to flash folder, right? So I'll show you where I just saved that out. So if we go, like you want to go to that GitHub folder where the Java configurator is, and then go to, there's a files to flash folder. And then it's this TSDZ8 underscore config.hex file that I just saved out right now, right? So it's 6:45 p.m. So look at the date modified. It always just kind of overwrites this file, right? This TSDZ8 underscore config.hex. So that's where the file is that we want to flash that contains all of my settings right here that I've just saved out. And so the main thing, like when I first started doing this open source firmware, I think I had to check this calibrated checkbox and check the torque sensor advanced checkbox. And then for the pedal torque ADC step, I had to change it to 12. I don't think the ADC step advanced matters. It's just the pedal torque ADC step, I would use 12. And then the pedal torque ADC offset, no weight. This value is a really weird deal where there's this whole like process that you have to do to figure this value out to calibrate your torque sensor, because apparently like each torque sensor in each motor can be slightly different, and you'll get different like ADC values from it across different motors. And the factory Tongsheng, like I never had to calibrate the torque sensor. I think it calibrates itself somehow right when you turn it on. But with this open source firmware, I don't know if it has like an automatic torque sensor calibration, or at least they haven't developed it yet. So with the open source firmware, I had to go through this whole process to figure out the pedal torque ADC offset, so that like it was like there's this value, there's like a debugging value that you can see on the screen. And so I configured some stuff within the configurator, like all this this number of data displayed at lights on I set to 6. And then so all of these advanced display settings, I changed these numbers so that the data points would show like ADC throttle, ADC torque sensor. That's the one that I needed to figure out, was that ADC torque sensor. So basically, like if you change this number of data displayed at lights onto 6, and then you change these numbers over here so that you've got the data points that you want, so ADC torque sensor 10B, this 6, just put the number 6 in one of these like data fields over here. Then on the EKD01 display, you can hold up the up button to turn the lights on. And when you do that, then it'll go here and look at this number of data displayed at lights on. And if you set that to 6, then it will display all 6 of these data points over right here, right? If you set number of data displayed at lights on to like 1, it'll only show the data 1, right? But if you set it to 6 like this, it'll show data 1, data 2, data 3, data 4, data 5, data 6. And then this time to menu items right here. So this is how long does it show those values when you turn the lights on. So I'll show you that in a second when we turn this thing on, how to look at these debug values. But that was confusing for me because if you have an EKD01 display, this was the only way that I was able to look at those debug values, was by like setting this up like this with these settings, right? So I'll show you that in a second, like how I got my ADC torque sensor calibrated. But ultimately, I came to these values, 215 for the ADC offset no weight, and then I got 479 for the pedal torque ADC max weight. But these two numbers are basically like the no weight or the ADC offset. That's kind of like what value does the torque sensor have at rest. So you basically spin the cranks backwards, and apparently, like, depending on the position of the cranks, the torque sensor ADC value can be slightly different. So what you want to do is back pedal with the cranks while you're looking at the ADC offset or the ADC value, and then see when you're going backwards, what is the biggest value that you see for that ADC torque sensor. And it'll be like, well, I think I was seeing like 20.3 to 20.5 on my EKD1 display. And then the number on the display, like there's actually like a conversion that is happening from miles per hour compared to kilometers per hour. So like if you're looking at the torque sensor value on the EKD1 display and it's saying 20.3, then you want to multiply that by 10, and that's the actual ADC value. And then the developer says to add like a margin of 10 on top of that. But the pedal torque ADC offset is basically like what is the largest value that you see from the torque sensor when there's no like pedaling or load on the torque sensor. So you just like spin it around, look at the values that you're seeing, and then just remember what's the biggest value. And then to calculate the max weight, it's kind of the same thing, except for I put my bike up against the wall, and then I basically just like, I was basically like pedaling the torque sensor and like bearing down on the crank as hard as I could, kind of pedaling the bike into the wall and putting a load on the torque sensor. And then you want to use the biggest value, like when you push down on the torque sensor as hard as you can, you want to look at the biggest value that you see for the ADC torque sensor. And I think in my case I saw 47.9 on the EKD01 display, and then I multiplied it by 10 to get to 479 for the pedal torque ADC max weight. I think for the max weight you could probably just use 450 or like 460 as your value, and that would probably be fine. Like I don't know if you have to really calibrate the max weight, but I guess like the pedal torque ADC offset no weight is important, because if it's too low, then the motor might want to go when you're not actually like putting pressure on the torque sensor, right? So that is why the developer recommends that when you find this ADC offset no weight, he recommends that you add 10 to it just to create a small buffer so that the bike doesn't think you're pedaling when you're not actually pedaling, right? So I'll show you how it displays, like I'll show you how we can see these debug values using the display advanced settings in a second. But right now, I'm gonna flash this on there. And I've honestly been having some problems with like this error. It thinks I'm getting like an overcurrent error, but my watt meter says that it's not. Like I think the controller thinks it's going above 30 amps of battery current. Then on my watt meter, it says it's only doing like 19 amps of battery current. So there's kind of like a weird situation going on here that's confusing me. But I'll show you how we flash this on there, right? So like I've compiled the hex file. It's saved out this TSDZ8 config hex file, ready in files to flash folder. Then we go over to the JFLash. We connect to the target with the JFLash. We open up the data file that we saved out. So that's TSDZ8 config.hex. So I saved that out just now, 6:54 p.m. So we're going to open up this data file with our configuration in the JFLash. And so this data file, it's only the configuration. Like it's not the firmware, right? So we've got the open source firmware that we flashed on here already. Now we need to flash this on top of it without deleting what's already on there, right? Like we want to keep the open source firmware that we flashed on there, but we also want to write this over it. So how you do that is you go, when we're flashing the configuration, we go to Target, Manual Programming, and then I think you can do either Program or Program and Verify, but I just do Program. I am actually going to change something here before I do this. I'm gonna change this a little bit to a different mode because I've been testing EMTB mode and there's all these other modes, but I'm gonna put it in hybrid mode this time and try a different one because I want to see if there's just something wrong with the EMTB mode that's causing my problems or what. So I haven't tried hybrid yet, so let's try that. So we can go into, not exactly sure where the hybrid assist mode gets its settings from. I'll just use the default, I guess. But so I changed that to the hybrid assist mode. So let's save out the configuration hex file again. I'm gonna close this one that I loaded. So I'm gonna load that most recent one that I just saved out right now. So this should be in hybrid mode now. And so we're gonna go to Target, Manual Programming, Program. And that's how we flash the configuration on top of the open source firmware without deleting the open source firmware. Right, so now I'm gonna do Target disconnect. I'll just close this JFLash without saving. So we should have this configuration flashed onto the TSDZ8. So that's basically it. Like the open source firmware should be there. We should have it flashed on there, right? We did the open source firmware, we did the configuration. That's everything. So now I'm going to disconnect the programmer and then I'm gonna plug back in my battery and then we'll turn this on. And so you'll know that you have the open source firmware installed when it looks a little bit different when you start up. So let's turn it on. See, it's showing my battery voltage right now. And then it goes back to 0. Kind of weird, but you'll know when you have I think you can kind of change which value shows up here by default. I think by default, the configurator, it'll show you like your state of charge. So when you turn on your e-bike, most of the time it'll say like 99.9, and that's representing like the battery state of charge. But I kind of like it how when I turn it on, it shows the voltage of the battery instead of that. So I can see, okay, 53.8, so I'm charged. So because I kind of like that because this display doesn't show the exact voltage, like it just shows like a averaged value. So it's good I don't mind seeing the voltage on the screen when I turn it on. And it also kind of lets you know that you have the open source firmware on there. So now we have the open source firmware on here. And I haven't actually tested hybrid mode at all yet. But so in pedal assist 0, like the throttle's not going to do anything. I've noticed that pedal assist 1, the throttle doesn't seem to do anything. And it's really weird. Like I can hear something, but it's not doing anything. So like, and I've noticed that in the EMTB mode too. When I have the pedal assist on 1, the throttle doesn't do anything. So really weird. But it does if you're actually pedaling. So I don't know if the pedal assist 1 on this thing doesn't use enough power to like overcome like the cogging and like the magnets of the motor or what. But it's kind of weird how the throttle doesn't work when it's in pedal assist 1, but you kind of hear something. Like I can kind of hear like the rotor trying to spin or something. Listen. Like I can hear something happening in there, just barely. But it's like I've noticed that I have to turn it on to pedal assist 2 before the throttle actually works. And so pedal assist 2, we're getting so it said 1.29 amps peak right there. All right, so I'm gonna put this thing in pedal assist 5. And then, so I'm just gonna go through, I'm gonna get all my gears going just so I can see how fast this thing is going in each of the gears on my bike. So I'm starting in second gear. So let's see, we'll just get it going full speed. So it seems like second gear can go 12 miles an hour. Third gear goes 15.5. Fourth gear goes about 19. Fifth gear goes 21.7. Sixth gear is 25.6. Seventh gear is 29. Eighth gear, 33. Ninth gear is about 39 miles an hour. And I think 39 miles an hour might actually be where the display is making the speed limit. I think I have it set so that the display sets the speed limit. And right now I think it's set to like 37 miles an hour, 39 miles an hour, or something like that. So it does seem like when I'm running it in the stand, like I didn't have many problems with that really. It says 161 watts peak, and I think it said like 1.5 or 1.6 amps or something with no load on the bike. So it actually does say it was using 3 amps at some point. Interesting. All right, so I guess like I'm gonna go try this out a little bit because I've been having a lot of problems with this, and I guess like when I come back, we'll just kind of talk about that, about all the problems that I've been having. Yeah. So in pedal assist 1, I saw 10.2 amps, 535 watts peak. Pedal assist 2, it did not seem to go above 10 amps. So somehow pedal assist 1 is giving me more power than pedal assist 2. Pedal assist 3 says 11.55 amps. Barely any more. 604 watts peak. I don't know. Pedal assist 4 is giving me 16.55 amps. Or 856 watts. So pedal assist 5, I managed to get to 17 amps. I'm not sure if pedal assist 5 is doing more than 4. 879 watts. I haven't got the error 7 yet that I was getting when I was in the EMTB mode. So I think there might be a problem with the EMTB mode. I'm gonna ride around a little bit more and see if I get any more error 7s in this hybrid mode. Alright, so I was just riding this thing around with those settings that I just created. I'm gonna start another screen recording on my laptop here right now. So I was just playing around with these settings, and it seems like it was working fine. I don't know, it was super weird. Like when I had it in the EMTB mode right here, I was getting problems. It seemed like it was whenever I would pedal extremely hard in the EMTB mode, I was getting an error 7 for some reason. So I think there might be a bug that is specific to EMTB mode and how it's calculating like the current to use based on the torque sensor. Seems like there might be a bug with that EMTB mode because like I kept getting error 7s, and it seemed like it would always happen whenever I was like riding up a hill and then I would pedal down on the torque sensor really hard in EMTB mode, I would get error 7. And error 7 is supposed to mean that there's like a battery current, like an overcurrent situation. And I looked at the code, like the source code, and it seems like whenever the battery current goes above 31 amps, it'll throw that overcurrent error, and then the motor will stop until you turn the display on and off. And that's what was happening to me over and over again in EMTB mode whenever I would pedal really hard, like going up a hill or something.
So I think right now there might be a bug in EMTB mode with the torque sensor and how it's calculating the current. But I just put it into the hybrid mode and it seems a little bit different, but kind of the same. Hybrid mode seems to be working. So I don't know if it's just like there's bugs with the different modes or what. I'll have to look into that a little bit further in the source code. And maybe try compiling like my own version of the firmware if I can find the bug. But I don't know. I guess maybe I'll test it out in hybrid mode for a while because that seemed like that worked better. And so in turn, it says 982 watts peak on my meter. And I think that 982 watts, I think that's the most that I've seen it do so far. 19.15 amps peak. 52.93 volts min. Yeah, so I think the hybrid mode seems to be working a lot better than EMTB mode so far. So I guess I'm gonna have to experiment around with this some more, guys. Like, I'm just getting into this open source firmware. I mean, maybe I'll get the Air 7 in the hybrid mode too, I don't know. My guess is like the developers, they probably have developed the modes that they use and that like the modes that are more popular and general purpose. And then maybe that EMTB mode still has like some bugs or not as many people use it and we haven't found the bugs in that one yet. So then the one other thing, like earlier I was talking about how we can go into the advanced settings and then the number of data displayed with lights on and then setting all these data things under the display advanced settings so that we can look at the debug values on the screen, and like that's how I calibrated the torque sensor. So you just go into the advanced settings like I discussed earlier and set number of data displayed at lights on to 6 and then change these data 1, 2, 3, 4, 5, 6 numbers. I use these numbers because I wanted to see like the throttle, I wanted to see the torque sensor, I wanted to see the pedal torque delta, and then it'll show battery voltage, motor temperature, and battery voltage again. And so that's how I flash the configuration to show the data when you turn the lights on. And so I'll show you how that works right now. How we can look at these debug values with the EKD01 display. So when it turns on, it's showing the voltage. That's like a setting that you can set in the configurator as well. But then so to view the debug numbers that we've set in the configurator, you hold the plus button. That's like to turn the lights on is when you hold down this. So just you use your display to turn the lights on, and then when the lights turn on, it'll say error 1, and then it's gonna go through all the numbers. Throttle, right? And then there is the torque sensor with no load on it. There's something else. There's the battery voltage. There's the motor temperature. And there's the battery voltage. And then it will go away. So that is how you can use this Java configurator and set the number of data displayed at lights on and set all those data things so that you can see the torque sensor on the screen. So like if you only wanted to see one thing, then you could just set number of data displayed at lights on to 1 and then make your data 1 the torque sensor or whatever, right? But I made it so it would show 6 data points. So let's see, the torque sensor is the second value. So first it shows the throttle, then it shows the torque sensor. So like if we go and we show the numbers again, so we gotta turn the lights off first and then turn the lights back on. So the throttle, let's play with the throttle. See, there's the throttle. 18.2, 4.2. Here's a torque sensor. I'm spinning it backwards. I saw it go up to 20.5. Right, so like when you're calibrating the torque sensor, you need to look at the ADC torque sensor 10B. And then how you do it is you get the ADC torque sensor 10B value showing on the screen, and then while you're looking at the screen, pedal the cranks backwards, so that doesn't apply any load, but it just moves the cranks and like the internals of the motor. And then so as you're pedaling backwards, you watch that ADC torque sensor value on here and see what is the biggest value that you see. So when I did it, I think I saw 20.5. Let's try it again. So I'm going to turn the lights off, turn the lights back on. So when that second number pops up, it'll be 20.3, and then I'll start pedaling backwards and it'll change. There it is. I'm pedaling backwards. 20.5 was kind of the biggest number that I saw. So you got to have everything set to miles per hour, and then if this thing says 20.5 for the torque sensor, you multiply that by 10 and you get 205, and then you add the 10, that margin that the developer talked about, and that's how I got the pedal torque ADC offset no weight. Like that's how I got that number right there, which is important, so that the controller knows like when the torque sensor doesn't have any weight on it and what is the difference, right? So that's how you calibrate the torque sensor. Is this basically, it's just this pedal torque ADC offset no weight. You want to figure that out, add that 10 to it, so it's got a little bit of safety margin on there. If the ADC offset's too low, the bike could just start going when you're not pedaling, so it'd be like ghosting a little bit. For the pedal torque ADC max, like I said, you could probably use like 450 or 460 or something. I've got 479. I saw 47.9 on my display is the biggest torque sensor number that I saw. But that's basically how you get the open source firmware on the TSDZ8. I was actually a little bit bummed out because yesterday, like, I was having so many problems with that EMTB mode, but I'm glad that I tried this hybrid mode because it seems to be working better. So this has kind of been my first adventure into programming the Tongsheng TSDZ8 mid-drive motor with the mstrens OSF open source firmware and using this configurator and this J-Link thing and all that. So I'm kind of new. This is all new to me. I'm just kind of figuring it out. If you have any experience with that Air 7 and the EMTB mode, or you have any idea about that, let me know. I was looking at the code. Like I was looking at the source code, but it's gonna take some digging to figure out like what exactly was going on in the EMTB mode. It just seems like there was, I was looking at the code earlier, but it just seemed like there was some kind of a problem going on in this EMTB mode. So that's in ebike_app.c is a source file, and there's static void apply EMTB assist. I think there might be something funky going on in here when it reads the torque sensor value and then it calculates how much current to use. So I might look through this code and try and see if there's like a bug anywhere where it can where the torque sensor value can cause the battery current to like spike to some weird high value that would cause an error. But I don't know. For now, I would recommend maybe trying this hybrid mode. It seems to work. I didn't get any errors with it. Just pedaling around briefly outside. It does seem that like for whatever reason, it does seem that like the open source firmware is not quite as powerful as the factory firmware. Like I think that the factory firmware, it must have been doing like 22 to 24 amps or something. Like it felt a little bit more powerful when I was running the factory firmware in terms of just like the raw like power. Like it just felt like it was using, I don't know. I mean, it felt like it was probably using like 300 or 400 watts more when I was using it with the factory firmware. But the thing about the factory firmware that kind of sucks, and the reason that you might want to try the open source firmware, is that the open source firmware has all these different modes and like all of this. There's a lot of options here for configuring everything, but you just kind of have to like work your way through the bugs and any like weird issues that you might run into, like that problem I was having with the EMTB mode. But it's kind of like, I do think that the factory firmware that Tongsheng is putting on these motors now is pretty decent. Like, it's not too bad. The only problems that I had with it was that when you start pedaling with the factory firmware, it like takes a second. Like, you can almost pedal like a full rotation or like 2 rotations before the torque sensor kicks in. It was kind of like when you start pedaling, there's a delay for the torque sensor to kick in. But then as long as you were continuously pedaling on the factory firmware, the torque sensor felt pretty good. But then when you stopped pedaling on the factory firmware, it felt like the motor would slightly keep going for a second after you stopped pedaling. And that was a little bit annoying. But I kind of got used to the factory firmware. Like, you can kind of get used to it. Like, after a little while of your bike, like, I got used to it and I was just kind of living with it. And I was pretty happy with it. Like, it wasn't perfect, but it was like 95%. Like, it was close enough to where I could live with it. And so I do think that, you know, there's a lot of value proposition in this TSDZ8 where you can get it for like $300 or like $325, the whole motor kit. And then there is this open source firmware. I'm going to keep playing around with it. I'm glad that hybrid mode works better because I was about ready to give up on this thing when I was using the EMTB mode. So I am going to keep messing around with this. Let me know in the comments, like, if you've messed around with the TSDZ8 open source firmware. Let me know if you use that 860C version of it, where you can program it from the screen. I didn't want to buy the Bafang 860C display yet, unless this is something that I really want to use. I've kind of been struggling with this for like the past 2 days, trying to get the EMTB mode to work without throwing those error 7s constantly. So I think I might just try this. I'm going to start testing with this hybrid mode, and I'm going to probably like look at the code a little bit and see if I can find the bug in the EMTB mode. So I do think I will be experimenting with this further in the future and all these settings. So you'll have to let me know what you think in the comments. I think the hybrid mode, like, I think I could take that on an actual ride. I'm gonna have to test a little bit further, make sure I'm not getting any errors. But as long as I can get some error, as long as I can ride it to where I need to go without constantly getting errors, then I'll probably start using this hybrid mode. I'm maybe gonna play with it a little bit, like increase the amps a little bit or increase the power a little bit and see how much I can get the motor to pull with the open source firmware. Because so far, like, I've never seen it break 1,000 watts for some reason. Like, even when I set the battery amps to like 25 or something on here, I think I've tried like 28 battery current max, 28 amps, and I had the motor power max set to like 1500, but I was in the EMTB mode and I never saw it pull more than like, I don't know, I want to say like 18 or 19 amps. I never saw it pull much more than like 900 watts in the EMTB mode, and I was getting all kinds of errors in that mode. So yeah, this, I don't know. The verdict is out, guys. I don't know. I'm gonna have to test this further and try it out, but I hope this video was helpful. If you're curious or interested in how the Tongsheng TSDZ8 motor, how you can flash the firmware and get the open source firmware on there with this janky J-Link configurator thing, let me know what you think in the comments. Thanks for watching. Like and subscribe. I guess I'm gonna have probably a playlist with some more videos, you know, exploring the open source firmware and cataloging my testing adventures. So stay tuned, like and subscribe. I'll see you guys in the next video. Thanks for watching the e-bike builder channel. Peace out, bubs. Later. Here we go. Drop her down. Drop her down.